What we mean by solving literal equations is that we're solving an equation that has multiple variables in it for one variable. Now you guys are used to doing this in the context of taking an equation that is in like this form. Yes?
Good morning, Mr. Hinton. This is Mr. Rinker. Could you send Madison Baker?
This group would do such a thing.
So we use this skill, solving literal equations, and taking an equation like this. What are we looking at here? What is 2x plus 3y equals 7? Somebody almost said it. Standard form of a linear equation, right? And what are the other forms of linear equation we've looked at this year? Say it again. Y minus y1 equals m times x minus x1. That's the point slope formula. We've done that. The slope intercept form is y equals mx plus b. Now what we're going to do tomorrow is we're going to kind of do a quick review of graphing linear equations using the slope and intercept method. So one of the preemptory skills for doing that is being able to solve a linear equation that's in standard form for y. So we want to put this into slope-intercept form. So that's one of the ways that we've looked at it. Now what you'll do upstream from here in chemistry and physics is you'll have a lot of formulas that have different quantities that relate to each other. Pressure, mass, volume, distance, rate, time. You know, lots of different temperature formulas for Boyle's law of cooling, converting Celsius to Fahrenheit, a lot of things like that where you have to solve for a specific variable in a formula and then make your substitutions. So there's a lot of application to this, so the better you are at this, the better you're going to be in chemistry and some of the other classes that you're going to come up on later in school. Okay, so that's what we're going to have a look at today, solving literal equations. All right, so you ready? All right, so example 1, guys, we have, this is directly related to what we just said. This says solve for x. What would we most likely or most commonly do in this scenario? We would solve for, what would we normally do here? Solve for what? Solve for, oh my goodness. We just talked about this, converting standard form to what? Slope-intercept form. We would normally solve for y, but just as a point of exercise, the directions here say to solve for x, which means we want to get x by itself. So what's the first step of this process if we're going to get x by itself?
Minus plus 5 on both sides and 5y, but don't add 9 and 5y together.
We're going to add 5y to both sides, but we can't add 5y and 9 together. That's perfect because they're not what?
And divide by 2.
They're not like terms. Okay? So we're going to add 5y, and that gives us 2x equals 5y plus 9.
Divide by 2.
And then to get the x by itself here, we need to divide by 2. What do we have to divide by 2?
Everything.
Everything. Now, there's a couple ways you could show this. You can just go through the individual terms and divide every term in the equation by 2. Okay? Or we could do what? You divide this by 2 and divide this whole side by 2. And you'll see it both ways. Either way is correct. And when we're doing y equals mx plus b, we want to divide the individual pieces so we can see the slope and so we can see the y-intercept. All right? So we've got to divide everything by 2. And that's going to give us x equals 5 halves y plus 9 halves. Now, incidentally, if you solve this, the coefficient of y doesn't really tell you anything, but the 9 halves is the x-intercept. So this is the x-intercept, but that's not going to be important to us. The easiest way to find the x-intercept is to use the definition of x-intercept, which means what? Where y equals 0. So if I wanted to find the x-intercept, I would take my original equation and make y equal to 0, so no mas y. and then divide by 2, and you get x equals 9 over 2. That's the y-intercept of this equation, which we can use to graph. You could find the x-intercept and the y-intercept. That's 2 points, and that's all we need to graph the equation of the line. All right, but that's tomorrow. Solve 2x minus 6y equals 12. This time we are actually solving for y.
EA.
Okay. What was the first step to solve for y here? Subtract 2x from both sides. Okay, good. Don't be fooled by this negative sign right here. That negative sign belongs to the y term. It doesn't belong to the x term. The x term is positive, so we are going to subtract 2x from both sides. And when we do that, we're going to get negative 6y equals negative 2x plus 12. You can't combine those terms because they're not like terms. This is 12 minus 2x. That's the same thing. Why would we prefer maybe to write that as negative 2x plus 12? It looks like mx plus b, right? It looks normal. That's a great way of saying it. It looks like mx plus b. Okay, now divide everything through by negative 6. And that's going to give us y equals negative 2 plus 1/3 x, which we might prefer to write as y equals 1/3 x minus 2.
Can it be written either way?
Yeah, it can be written either way. Unless I specifically said to put it into slope-intercept form. Slope-intercept form really has to be mx plus b, so the x term would need to come first. Mac, what's your question?
What is the new part about this?
The new part is coming up. Okay. Let me go back and ask you a question about this original problem. See who remembers this as we're kind of reviewing and closing up shop for the year. 2x minus 6y equals 12. Is that in standard form?
No.
No.
Yes, actually.
I know why you.
Yes or no?
Yes.
Does anybody give me a no? What are the conditions for standard form? A, B, and C have to be relatively prime integers. Are these 3 integers relatively prime?
No.
They're not. They're all divisible by 2. So the standard form equation here would be x minus 3y equals 6. But you could do that at the beginning of this equation if you wanted to. Take half of everything or divide everything by 2 just to simplify things, right? You wouldn't need to do that to solve for x or y, but this would be the standard form of this equation. All right, just kind of a reminder there. All right, next example. We'll solve for x. We're not going to do that at this point. We're good for there. What about this one? Now, this one's a little bit different than any we've looked at before. X minus 5 over y equals 9. And this says solve for x. Now have a look at this one. Tell me what you think we should do. Multiply by y. What'd you say, Gray?
Never mind.
You said add 5. You can't add 5 because that 5, remember that a fraction bar is a grouping symbol. And so that 5 is locked up in a parentheses. It can't be, we got to get rid of the y before we can do anything with x or 5. Somebody said multiply by y. What's another thing we could do here? It's going to kind of be equivalent, right? Robert, you got an idea? Multiplying by y is a correct answer. No question about it. But what I kind of want you to learn to recognize is what we're working with here is a proportion. How do you solve proportions? You cross multiply, right? So we can write the 9 over 1, and then we have 9 over 1 equals x minus 5 over y. And then we just cross multiply, right? So we're cross multiplying. 1 times x minus 5 is x minus 5 equals 9y. Right?
Plus 5.
That's pretty easy to think of it that way rather than multiplying by y. Proportions, you can always cross multiply to solve. What is a proportion? What is a proportion? One fraction equals another fraction. Right? If you have a proportion is a statement that two ratios are equivalent, and anytime you have two fractions or two ratios, that's a proportion. Now to finish solving for x, what would we do here? Add 5 to both sides, and that's correct. This one actually may show multiplication by 5, by y, excuse me, so the y's would cancel on the left, and you left with that. But effectively, it's the same thing. Add 5 to both sides, and we get x equals 9y plus 5. Now, if we wanted to solve this for y instead of x, we would still need to cross multiply or multiply both sides by y. And at this point, to solve for y, we would divide by 9 instead of adding 5 to get the x by itself. All right, so you've got options. And that's one of the things that you're going to be approached with in chemistry and physics. When you have a formula that has multiple variables in it, and they tell you to find the temperature, for example, then you need to solve for t first. Identify that variable, solve for t, and then make your substitutions. Okay? Some teachers will not allow you to just make the substitutions and solve in context. You have to solve for the variable first and then make the substitution. And that's their prerogative. Now this one's new, Mac. 2m minus t equals sm plus 5. Now the directions here say to solve for m. Now what's different? There's 3 variables, right? What else is different? There's 2 different m's, right? M is in 2 different places. Now, how did we do this when we had x's on both sides of an equation we're trying to solve for x? What's the first thing we did in that scenario? We got the x's together. So in this case, if I'm trying to solve for m, I have to get the m's together. So I want your instincts to kind of kick in. We need to get these m terms together. All right? What else do we need to do to get the m's by themselves? Add t to both sides to get the t on the other side. So we want everything that has an m on one side, everything that doesn't have an m on the other side. Right? So let's do this in one step. I'm not sure what the PowerPoint's going to do, so I'm just going to write this in. To get the m's together, I'm going to subtract sm from both sides. To get rid of the minus t, what are we going to do? Y'all watch here. To get rid of the minus t, what are we going to do? Add t to both sides. Right? Now, can we combine any of these things? 2m and sm. The 2 and the s aren't like terms, so I just have to write that as 2m minus sm. And if you're not writing this down, you're going to be extremely lost in parts of your homework. All right, what are we going to have left on the right side of our equation? Do what? T plus 5 is correct.
Is this the answer?
No. What's the answer going to look like? M equals something, right? So any ideas? This is new. You've not run across anything like this yet. If we divide by S, that's going to give us, let's see what that would look like. Is that going to really help us if we divide everything by S? Is that going to help us? It's not. It's a good idea. I mean, it's something good to think about. It doesn't look like that's going to get rid of our problem.
Divide by 2.
Divide by 2 would be the same thing as dividing by S. It doesn't really get 1m, right? How can we get 1m here? Think about what the left side looks like right here. 2m minus sm. Anybody make a suggestion?
Divide by n.
Divide everything by m?
Combine.
That's the best suggestion so far, but it's still not perfect. Okay.
Add m.
Do what?
Multiply the first equation by S.
Multiply the first equation by s. No, that's not going to work. Okay, what have we spent more time on this year than any other single skill? Factoring. So to get m by itself so that we just have 1m, what can we do on the left side of this equation? We can factor out an m, and that'll leave us with 2 minus s equals t plus 5. Now what can we do? We can divide everything by 2 minus s. So here's what m equals. M equals t plus 5 over 2 minus s.
Okay, so it's not that difficult when you know how to do it.
Right, so the goal is to get the m by itself, right? So how do we, the way we get the m by itself here is to factor. Okay, and we've done that more than any single skill this year. We've done factoring more than anything because it applies all over the place. What did you say? Somebody said divide everything by m. Who said that? I think it was Rachel. If we went backwards and we took this thing and divided everything by m, because really, what is factoring? Factoring is unmultiplying, right? Which is similar to dividing. So if we divided everything by m here, if we divided these two things by m, and divide this by m, what are we going to have left on the left? That those m's will all cancel out, so we'll have 2 minus s equals t plus 5 over m. And then guess what we can do? You can cross multiply, and then you would have what? M times 2 minus s equals t plus 5, and then you could divide the 2 minus s just like we just did. Okay? It's more direct to factor out the m rather than doing division. Okay? All right? Well done. Let's see what this does. It's exactly the same thing. And let's try a few problems. This says with a partner, but let's don't do it with a partner. Let's just jump straight to 3 and 4. Try 3 and 4. Now, number 3 and 4 are both going to be similar to what we've done. Second, we're going to pause recording and give you a few minutes to do this.